So welcome. This is a test based upon complex numbers, 54 marks questions. So these are all taken from the past papers of IBDP. So let's solve it out. Some first question. It says the complex number omega and z satisfies the equation omega upon z equals to 2i and omega star minus 3 omega equals to 5 plus 5i. Find omega and z in the form of a plus ib. So now what has been given as omega upon z equals to 2i. What does that mean? By cross multiplication, omega equals to 2iz. Now he has given it out z star, which is conjugate, minus 3 omega equals to 5 plus 5i. So z star, what is going to be z star? Let us write as z star only, minus 3 omega, 3 times of 2iz equals to 5 plus 5i. So let us assume z equals to x plus iy. If I assume z equals to x plus iy, what will be z star becomes x minus iy. Conjugate means x minus iy minus 6i z equals to 5 plus 5i. So z also I'm going to plug in. So z star is x minus iy minus 6i times x plus iy equals to 5 plus 5i. Now real parts to equal to real parts, imaginary part equal to imaginary part. What is the real part? X is the real part over here. Minus 6i times iy is also going to be a real part and 5 is going to be a real part. So x minus 6i square equals to 5. 6i square y equals to 5. That's going to be the real part. So what does it becomes? X plus 6y equals to 5. Next, imaginary part equal to imaginary part. What is the imaginary part? Minus iy. And when I multiply negative 6i with x's imaginary part is 5. So what does that becomes now? Negative y, negative 6x equals to 5. Or write in properly, negative 6x, negative y equals to 5. Now I got two simultaneous equations. I'm going to solve it out, those two simultaneous equations. So multiply the first equation with maybe 6. So I get it out 6x plus 36y equals to 30. The second equation is as it is, negative 6x, negative y equals to 5. Add them, 6x, 6x gets cancelled, 35y equals to 35, which gives me y value is 1. Now plug in y value 1 over here, negative 6x, negative 1 equals to 5, negative 6x equals to 6, so x equals to negative 1. So what is the value of z? I got it. So z equals to negative 1 plus I. That's going to be the value of z. What else been asked? Find z and omega. But omega is 2iz. So omega equals to 2i times z, which is 2i times z is negative 1 plus I. So which becomes negative 2i plus 2i square. I square is negative 1. So negative 2i, negative 2, or write in standard form, negative 2, negative 2i. This is going to be the answer. Going to question number 2, which is a 20 marks question from 2020 paper 12. Use the binomial theorem to expand cos theta plus I sin theta whole to the power of 4. So what am I going to do that? 4c0 cos to the power of 4 theta plus 4c1 cos cube theta times I sin theta plus 4c2 cos square theta I sin theta whole square plus 4c3 cos theta I sin theta whole cube plus 4c4 I sin theta whole to the power of 4. Simplify that. 4c1 is 1, 4c0 is 1, so cos power 4 theta. 4c4 is 4, so 4 cos cube theta sin theta times I. 4c2 is 6 and I square is negative 1, so negative 6 cos square theta sin square theta. Then I cube is negative I. 4c4 is 4c3 is 4, so negative 4 cos theta sin cube theta times I, and 4c4 is 1, I power 4 is 1, so it becomes plus sin power 4 theta. So what am I going to do? I am writing in the form of, is asking in the form of a plus ib. So what I will do, all the real terms, cos power 4 theta minus 6 cos square theta sin square theta plus sin power 4 theta, then I common 4 cos cube theta sin theta minus 4 cos theta sin cube theta. So I got it out this one. Use De Moivre's theorem to show that cot 4 theta. So by basically from the De Moivre's theorem, what will happen is cos theta plus I sin theta when n equals to 4, cos theta plus I sin theta whole to the power of 4 becomes cos 4 theta plus I sin 4 theta. So I equate the real part equal to real part and imaginary part equal to imaginary part. So cos 4 theta, this is the real part and this is the imaginary part, equating it out. So from there I get cos 4 theta is cos power 4 theta minus 6 cos square theta sin square theta plus sin power 4 theta, whereas sin 4 theta will be 4 cos cube theta sin theta minus 4 cos theta sin cube theta. Now what is being asked? Cot 4 theta. We know that cot 4 theta is nothing but what? Cos 4 theta upon sin 4 theta. So copy down this cos 4 theta and write it out over here, divided by sin 4 theta. This is sin 4 theta. So I am writing both cos 4 theta upon sin 4 theta. Then what am I going to do? I am going to divide both numerator and denominator with sin power 4 theta. So for that, what can I do is I move this a bit up, or else I'll write it as in the next step only. What am I doing it out is cos power 4 theta minus 6 cos square theta sin square theta plus sin power 4 theta divided by sin power 4 theta. Total divided by 4 cos cube theta sin theta minus 4 cos theta sin cube theta divided by sin power 4 theta. So when I do that, I am directly writing the answer. Cot power 4 theta minus 6 cot square theta plus 1 divided by 4 cot cube theta minus 4 cot theta. Use the identity from part B to show that the quadratic equation has these roots. So what is that? Setting it up, cot 4 theta equals to 0. We take cot 4 theta equals to 0. So when I take cot 4 theta equals to 0 and let x equals to cot square theta. So this one we have done it out. Cot 4 theta equals to 0 and we take x equals to cot square theta over here. So what do I get? 0 equals to cot square theta whole square minus 6 cot square theta plus 1 divided by whatever may be the denominator, because anyway when you do the cross multiplication the denominator becomes 0. So it becomes x square minus 6x plus 1 equals to 0. So now what I am supposed to do it out? This equation is nothing but what? The given equation x square minus 6x equals plus 1 equals to 0. So when is that possible? When cot 4 theta equals to 0. So tan 4 theta equals to infinity. So 4 theta equals to n pi plus pi upon 2, because tan inverse of infinity is pi by 2. So now what am I going to do? Substituting n equals to, or else from there theta equals to n pi by 4 plus pi by 8. N equals to 0, so I get it out pi by 8. N equals to 1, I will be getting it out 3 pi by 8. So those are the two roots. Pi by 8 and 3 pi by 8 are going to be the two roots. So the roots are pi by 8 and 3 pi by 8 are going to be the value of theta. from there, but he's asking it is having cot square pi by 8 and what is this? Cot square 3 pi by 8. So x equals to cot square theta. So x equals to cot square pi by 8 and x equals to cot square 3 pi by 8. That's going to be the answer. Hence, find the exact value of cot square 3 pi by 8. How should I be finding it out? The exact value of cot square 3 pi by 8. So we know that x square minus 6x plus 1 equals to 0. Use the quadratic expression minus b plus minus square root of b square minus 4ac upon 2a. So you'll be getting it out 3 plus or minus 2 root 2. So cot square, we know that cot square pi by 8 is greater than cot square 3 pi by 8. So therefore, what is this? Cot square 3 pi by 8 should be the smaller one. It should be the smaller value. So which is that one? Cot square 3 pi by 8 equals to 3 minus 2 root 2. Deduce a quadratic equation with integer coefficients having the roots cosecant square pi by 8 and cosecant square 3 pi by 8. So let y equals to cosecant square theta. So we know that cot square theta equals to cosecant square theta minus 1. So, but we assume that cos square theta was x. So x equals to cosecant square theta minus 1. So what is cosecant square theta? Cosecant square theta is x plus 1. X plus 1. So now what is this? I want an equation which are having nothing but what? Cosecant square theta x plus 1 as a root. So what will become? X square minus 6x plus 1 equals to 0. Because you are adding 1, so you should be subtracting 1 in the new equation. Y minus 1, opposite operation, plus 1 becomes minus 1. So x plus 1 becomes y minus 1 whole square minus 6 times of y minus 1 plus 1 equals to 0. So y square minus 8y plus 8 equals to 0. That's going to be the answer. When you got x plus 1 over here, so in order to get the equation with that one, we have to do it out the opposite operation, y minus 1, and you get it out the equation. Question number 3. Consider the complex numbers z1 and z2. Find an expression of z1, z2 in terms of b. So z1, z2 equals to 1 plus bi times 1 minus b square minus 2bi. So it becomes 1 minus b square minus 2i square b square plus I times minus 2b plus b minus b square. So what does it becomes? 1 plus b square plus I times minus b cube. This is b cube. This is going to be the answer. Given that argument of z1, z2 equal to pi by 4, find the value of b. So argument of z1, z2 equals to r tan minus b cube upon 1 plus b square equals to pi upon 4. So from there, negative b cube upon 1 plus b square equals to tan pi by 4. Tan pi by 4 is 1. Cross multiplication, negative b cube equals to 1 plus b square. So from there, I will be getting it out. B cube plus b square plus b minus 1 equals to 0. So what is that going to satisfying it out? B equals to negative 1 will satisfy. For this one, you can use the calculator and get the value of b as negative 1. Question number 4. Consider the complex number z and omega. Find the modulus of z omega. So absolute value of z omega is absolute value of z times absolute value of omega, which is 2 and 8. 2 times 8, which is 16. Find the argument of z omega in terms of k. Argument of z omega. equals to argument of z plus argument of omega. So which is argument of z is pi upon 5 plus argument of z omega is minus 2k pi by 5. So if I want to simplify it out, 1 minus 2k times pi upon 5. Find the minimum value of k. So he gave that z omega belongs to z, means argument of z omega should be is a multiple of pi. Is a multiple of pi. So there should be no denominator. So it makes 1 minus 2k is a multiple of 5. There should be no denominator, so 5 should be cancelled. So 1 minus 2k should be a multiple of 5. So minimum value of k should be equals to 3. If k is 3, then it will become a multiple of 5. Then it will become 1 minus 6 upon 5 times pi. Then it becomes negative pi. So I don't get it a denominator over there. Next part C2, for the value of k found in part 1, find the value of z omega. Z omega will be equals to absolute value of 16 cos of, what was that value? Negative pi, plus I sine of, what was the angle? Negative pi. Simplify that, we will be getting it out negative 16, because sine pi is 0, cos pi is negative 1. Question number 5. Z power 4 equals to minus 4. Solve the equation giving the solutions in the form of a plus ib. So absolute value of z will be 4th root of 4, which is nothing but what? Square root of 2. So what am I going to do this? Instead of doing in that way, I can do it out in another way. What is that is? Z power 4 equals to negative 4 times 1. So z power 4 equals to negative, or else take it out 4 in negative 1 inside. So negative 1. So z power 4 equals to 4 times negative 1 plus I times 0. So z equals to 4th root of 4, then minus 1 plus I negative 1 plus I times 0 whole to the power of 1 upon 4. So 4th root of 4, just now we have found it out, it was square root of 2. Square root of 2, then this is cos 180 plus I sine 180 whole to the power of 1 upon 4. So by De Moivre's theorem, it becomes root 2 cos 2k pi plus pi upon 4 plus I sine 2k pi plus pi upon 4. And what are the k values? Start from 0, 1, then what is this? 2 and 3. Start from 0 and go up to 3. So when I'm going to do that one, I'm extending into the next page also. So I'll come back to part B. So z1 equals to, when it is 0, so root 2 cos pi upon 4 plus I sine pi upon 4. Cos pi upon 4 is 1 upon root 2. Sine pi upon 4 is also 1 upon root 2. So it becomes 1 plus I. So z2 will be again root 2, n equals to 1. K equals to 1. So what does it becomes? 3 pi upon 4. Cos 3 pi upon 4 plus I sine 3 pi upon 4. So what am I going to do? Root 2 cos 3 pi upon 4 is 1 upon root 2. Sine 3 pi upon 4 is plus 1 upon root 2. So minus 1 plus I. So once you got it out 2, what you can do it out is, the other 2 will be, you need not substitute and waste your time. They will be the conjugate, 1 minus I, and z4 will be negative 1, negative I. So I got it out 4 answers. What are those 4 answers? 1 plus I, 1 minus I, then minus 1 plus I, and negative 1, negative I. These are the 4 roots for that one. Now come to part B, the solutions from the vertices of a polygon. In the complex number, find the area of the polygon. So what am I going to do? I am going to draw the polygon. 1, negative 1, 1 and negative 1. The first one is 1 plus I. X is 1, Y is 1 over here, and minus 1 plus I, minus 1 minus I, and minus 1 plus I. So clearly we can see that it forms a rectangle. The four roots forms a rectangle over there. I can expand this one rather than, okay, so maybe I can get a proper rectangle over there. Okay, so those are the 4 points forming a rectangle, and we know that this distance is 2, and our square, this distance is 2, so area is going to be 2 times 2, which is going to be 4. 4 is going to be the area of the polygon. We can call it as a square also. Coming to question number 6, so what is he asking is about what it says: determine the roots of this equation z plus 2i whole cube equals to 216i, giving your answers in this form. So z plus 2i will be equal to 216i. That 216i is written in the form of nothing but what? 216 0 plus 1 times I. So z plus 2i whole cube equals to 216. This is cos pi upon 2 plus I sin pi upon 2. Now the cube from left side becomes a cube root. So cube root of 216, then cos of pi upon 2 plus I sin pi upon 2 whole power 1 upon 3. Where now I'll be using it on what? De Moivre's theorem, and I can multiply the 1 upon 3 with the argument. Before that, cube root of 216 is 6. Then this is cos 2k pi plus pi upon 2 by 3 plus I sin 2k pi plus pi upon 2 upon 3, where k equals to 0 plus 1 and negative 1. So this is z plus 2i. I want the value of z. So when I take 0, so I get z1 plus 2i equals to 6 times of, I'm directly writing it out, you'll be getting it out cos pi upon 6 plus I sin pi upon 6, which is giving me the value as 3 root 3 plus 3i. So my z1 will be 3 root 3 plus I. Next, I'm going to take the value of k as plus 1. So z2 plus 2i equals to 6 times of cos of 5 pi by 6 plus I sin 5 pi by 6. When I simplify that, I will be getting it as negative 3 root 3 plus 3i. So what will be my z2 will become negative 3 root 3 plus I. And finally, I am taking it out. What is this? K value as negative 1. So z3 plus 2i equals to 6 times of cos 3 pi by 2 plus I sin 3 pi by 2, which is going to be negative 6i. So what is z3 will be equals to negative 8i. That's going to be the answer. So that completes the paper. See you in the next paper. Bye.